What we're going to talk about in this video is distribution, or the distributive property in action. And so we're going to start with how it works using a very simple example. Say we took 5 and we're going to multiply 5 times the sum of 2 plus 4. Well, first let's think about this. If the direction said evaluate, right? If we were to evaluate this, I would look and I'd say, well, first off, I have the number 5, and there's an implied multiplication sign right there. So this is 5 times the sum of 2 plus 4. So if we worked off to the right side, evaluating this problem, we would say that that's 5 times 6. And since they're both positive, a positive 5 times a positive 6 is positive 30. And that would be the proper way to go about evaluating this problem. But what if it actually asked me to do something different? So let's say that the instructions were to rewrite using the distributive property. So what we're going to do then is talk about how we distribute. We're going to take our first term, 5, and we're going to multiply first by the value of 2. Okay, so we're multiplying 5 times 2. And then we're going to add that to 5 times 4. Then we're going to use our order of operations now and evaluate the multiplication piece first. So the product of 5 and 2 is 10. And the product of 5 and 4 is 20. And now the sum of 10 and 20 is 30. So we get the same answer. Notice 30 was our original answer and 30 is still the answer. The concept of distribution doesn't change the answer, it just allows us to handle situations in a different way. Now if I were to see the original problem, 5 times 2 plus 4 in parentheses, I would use the first method. Using the distributive property for this particular problem to evaluate it really isn't the right way to go. The original way we attacked it would be how I worked it. But let's try a different problem and see if we can understand what distribution is all about. So the example I'm going to use is food. Why? I like food. So although the version I'm about to use may not be the healthiest of meals, let's say we were just out to cheat a little bit and we wanted a little junk food. And so we're going to go to a fast food restaurant unnamed, and we're going to go for a combo meal. And some friends heard that you were leaving to go, and they said, hey, we want the same combo meal. And you have 2 friends, not all together, but you happen to be talking to 2 friends, plus you, that's 3 people. And everybody's going to get the same meal. So what we're going to do is get 3 of these meals. What we're going to do is use the distributive property and this concept to discuss how this works. So what I have is a picture version of what we're talking about. And again, we're getting 3 of these combo meals. 2 cheeseburgers. Here's my 2 cheeseburgers. Couldn't really get a good brown, so I used a pink. Let's call them medium rare burgers. And a little bit of lettuce and the bun. Best I could do. And we have our French fries here, and we have our drink here. So each meal comes with 2 burgers, 1 fry, and 1 drink. And I'm going to order 3 of these. So what does it look like when we get 3 of these meals? Well, here we are. I'm getting hungry just thinking about it. Let's count up. What do we have? We have 2 cheeseburgers here, 2 cheeseburgers here, and 2 cheeseburgers here. What do we have? We have 6 cheeseburgers. Then we have 1, 2, 3 fries. So 3 FF French fries. And then we also have 3 drinks. And let's count them. We got 1, 2, 3 drinks. Well, that's interesting. 3 times 2 is the 6 burgers. 3 times 1, because there's 1 medium fry per group, gives me 3 fries. And 3 times the 1 drink gives us 3 drinks. Let's take a look at this in a little more algebraic fashion. So what we had, our original problem, was 3 times this combo meal program. And what we're talking about is multiplication. Distribution is just fancy for multiplication across a certain number of terms. 3 times 2 added, that's our first set of arrows, added to the 3 times 1 added to the, all the way in the end here, our 3 times 1 again. So that's going to be 6 cheeseburgers plus 3 French fries plus 3 drinks. Let's try this in an extremely algebraic fashion. Say, for instance, we had 7 times 3x plus 4. Again, notice how up here I use the arrows to help guide my direction of thought. This reminds me that I have to multiply 7 times both of these terms. So the first thing I want to write is 7 times 3x, and that is going to be added to 7 times 4. Now I want to evaluate 7 times 3x, that's going to be 21x, and 7 times 4 is 28. That's going to be my final answer because these are not like terms, and that's why we already discussed about what like terms are. Now you see, in my first example, that's sort of 5 times 2 plus 4. Since 2 and 4 are like terms, it's easier to just go ahead and combine like terms and evaluate that as a final answer of 30. But over in this other example, 3x plus 4 are not like terms, so I can't add them together. So how do I go about evaluating this expression? I use the art of, or the property of, distribution, and I get my terms that I can deal with on this second layer here, evaluate those, and I stop where I can go no further. Let's take that same problem we were just working on, but we're going to change one thing. Instead of 3x plus 4, it's going to be 3x minus 4. So the first thing I do is draw those arrows to help me remind myself that I have to distribute or multiply 7 times 3x and 7 times the negative 4. So my first group here is going to be 7 times 3x. And the next thing I need to pay attention to is I'm going to add that to 7 times negative 4. Okay. When I evaluate the 7 times 3x, I'm going to get 21x. And when I evaluate the 7 times negative 4, that's a positive 7 times a negative 4, it's going to be negative 28. And that's our final answer. Slightly different from our last answer. Okay? Are you taking notes with me? Are you writing this down, or are you just watching? If you say, I'm just watching, I would highly recommend that you go back and make sure that you copy all these examples into your notes. That's what helps solidify all the material. Okay, why don't you follow along with the next one, step by step, writing it with me. Let's first draw our arrows in, and now we have, on the next line, it's going to be 7 times negative 3x. We should probably put that in parentheses. And we're going to add that product to 7 times positive 4. When I bring these two down to the next layer, 7 times a negative 3x is a negative 21x, and 7 times 4 is 28, and this is going to be positive, not so much because this sign was positive, but a positive 7 times a positive 4 is a positive 28. The signs that we're writing here are the result of the products. And so I need to understand that negative times a negative is a positive, so on and so forth. Same signs yield a positive answer, opposite signs yield a negative answer. This was a positive 7, and maybe you want to write positive 7 times the negative 3x to help you out. Let's try to rifle through a few more examples. Moving right along. First things first, let's draw our arrows to help me remember that I have two terms to distribute across. And so now we have a negative 8 times a positive 2x added to a negative 8 times a negative 6 So on my next layer, I'm thinking about products. A negative 8 times a positive 2 is a negative 16x, because it's 2x. And negative 8 times negative 6 is positive 48. That's our final answer. Now notice all of my answers tend to have the variable expression first and the constant second. That's how I'd like to express all my answers, even if their original order doesn't look like that. Let me explain a little bit more using an example. Okay, so this has a couple of uncomfortable moments. First, that variable expression, 5x, is the second term inside the parentheses, not the first, and we have a negative on the outside. Well, how's this going to work? Slow and steady. Just take your time. First and foremost, let's rewrite it. Negative 9 times 3 plus a negative 9 times a negative 5x. Okay? And we sort of just peel the layers of the onion away. Next level, negative 9 times a positive 3 is a negative 27. And a negative 9 times a negative 5 is going to be a positive 45, and it's going to be a positive 45x because it's negative 9 times 5x. Now this is a reasonable answer, and I think most math teachers, at least at the Algebra 1 level, would mark that correct. But we'd really have a preference to write things in a certain order, and we like the variable expression to come before the constant. Now what's interesting and tough to navigate here is that the 27 was negative originally, and it still is. That negative sign is in front of the 27. And the 45x was positive, and it still is. The omission of that positive sign is there, it's just implied. So both of these are reasonable answers, but this is really the preferred answer. Let's keep going. Well, now the world has really shifted beneath our feet, and what has happened? The value to distribute is on the right side. What can we do? Well, first realize that this whole term is in a grouping symbol, so to make it more comfortable, one thing you can do is rewrite it like this. Now that's not something I would recommend to continue to do forever, but maybe as a starting example. So I'm going to work both of these problems in tandem. For the first version, I'm just going to put my arrows like I would, but from the right side. Over here, I'm approaching it from the left side. On the first example, I'm just going to say 5 times negative 12 plus 5 times 3x. On the right example, it's still 5 times negative 12 plus 5 times 3x. And at this point, I have equivalent expressions. So I'm just going to continue to work on the one on the left since they're both identical at this point. The next level, 5 times negative 12 is a negative 60, and 5 times 3 is a positive 15, and therefore 5 times 3x is positive 15x. And again, a reasonable place to stop, but the preferred answer would be 15x minus 60. Again, taking note that the 60 was negative, and it still is, and the 15 was positive, and it still is. Well, now we're approaching the best stuff here. It's getting juicier. I have distribution here, and I have distribution here. Double distribution. No big deal. I'm just going to attack them one at a time. Draw my arrows in, and now I'm just going to sort of isolate my thought process. So on the left side, I have 3 times 8x added to 3 times negative 4. On the right side, as I sort of make my way across here, this is a positive 5, so I'm just going to say, well, continue my thought process, plus 5 times 6 plus 5 times 8x. All right. So on my left side here, I'm going to evaluate what's happening. The 3 times the 8x is going to leave me with a 24x. Positive 3 times negative 4 is a minus 12. Positive 5 times 6 is positive 30. And a positive 5 times 8x is positive 40x. Now, I'm going to combine like terms. Whose like terms? Positive 24x, positive 40x becomes a positive 64x. And then the negative 12 and the positive 30 yields me a positive answer, because 30 is positive, it's bigger than 12, and the difference of 30 and 12 is, is a positive 18. And so that's our final answer. I'm going to do one more big one and then we'll call it quits for today. All right, we got a lot of stuff going on here. There's lots of varying signs to make this a little bit more challenging. But again, we're going to take this slow and steady. On the first level, I'm just going to rewrite it. So this is 7 times 3 plus 7 times negative 4x plus a negative 6 times 4 plus a negative 6 times 9x. Okay, well, what is 7 times 3? That's 21, and it's positive because they're both positive. The next product is a positive 7 times a negative 4x, so that's a negative 28x. The next line is a negative 6 times a positive 4, so the sign is going to be a negative 24. And the next sign, negative 6 times a positive 9, is negative 54x. Now let's combine like terms. Who are the like terms? Well, the negative 28x and a negative 54x add up to be a bigger negative. That's going to be negative 82x. And then my positive 21 and negative 24, the result of that is going to become a negative, because 24 is negative and it's larger than 21, and their difference is 3. Notice I wrote the variable expression first. It's not an absolute must, this negative 82x, but it's preferred. So that's our final answer. Some of these can get a little challenging. To wrap things up, I just want to take a look at this last problem again and show how eventually we would like you to be tackling this. Eventually, we just want to sort of take it as we go and say positive 7 times a positive 3 is a positive 21. And then a positive 7 times a negative 4x is a negative 28x. Followed by a negative 6 times a positive 4 is negative 24. And negative 6 times a positive 9 is a negative 54x. Sorry about that, negative 6 times 9x. And then we have the same situation here. So we have our negative 82x minus 3. That rewriting is to first get you into the mode of doing this. Eventually, we want you to graduate to this level. But it's in baby steps, one step at a time. I know this one was a little bit longer than usual, but it is important that you get all of these skills because, again, we're always building, building, and building towards bigger and better problems. See you next time.